In this tutorial, we're going to cover how to create a very simple class with some instance variables, and we'll also instantiate that class and create the equals and the toString functions or methods within that class. So this should be a review of some of the material that you've previously had. To begin with, you'll notice that inside of NetBeans I have a simple solution and project here, no code yet in main. And the first thing I want to do is create a new class. So let's right-click on our project and select New Java Class. We'll give it a name, and in this particular example I'm going to create a candy bar class, and then we'll define some things that the candy bar knows and also some things that the candy bar can do. Okay, so now we've got our candybar.java, and inside of our public class candy bar we're going to put all of the information that we need about it. So let's set up the private instance variables, and the first thing I'm going to have is a private string name. So this is going to be something like Snickers or Three Musketeers. I'll also want to count the calories in this particular candy bar, and I want to know how much the candy bar weighs. And the final thing that I'd like here is I want to know how much the candy bar costs. Okay, so these are going to be our instance variables, and these are the things that the candy bar knows. It's got a name, how many calories, what's the weight, and the cost. And the next thing we need to do is set up the constructor for this candy bar. And if you recall, a constructor's purpose is to initialize all of the instance variables and ensure that every time I instantiate an object of this class, it will have all of the attributes or all of the variables, instance variables, set up properly. So I need to create a default. In this case, my constructor takes no parameters, so I'm going to set up the name to be called nothing bar, and I'll set the calories to be by default 280, and the weight to be by default 2.07, and the cost to be by default 75 cents. Okay, and if you're guessing where I'm getting these numbers, I'm actually looking at a Snickers bar here as I'm coming up with this. So we could have changed the name to Snickers if we'd like, but this is a typical candy bar of a particular kind of average weight and cost and calorie count. Okay. In addition to having a constructor without any parameters, we can define one that takes in the 4 parameters: name, calories, weight, and cost. And the purpose of this constructor is going to be that if I want to initialize the properties of the object, I can just pass these in. You'll notice that I've put these underscores in front of the parameters, and this is just a stylistic choice. You could just leave those off, and if you do, you need to make sure that you're using the this reference when you do the initialization. So I'm going to set the name, which of course is our private attribute here, to be underscore name. I'm going to set the calories to be underscore calories, and you should probably see the pattern here. I'm going to set the property weight to be the parameter underscore weight, and finally I'm going to set the cost, the property cost, to be the underscore cost parameter. Okay, so now if you call the candy bar and you create a new candy bar object, if you pass it nothing, then this constructor will be run, and if you pass it these 4 parameters, then this particular occurrence of the constructor will be run. Okay, so we've done this manually, but what I'd like to do is show you a bit of a trick here. And inside of NetBeans, you have a nice feature wherein you can come under Source and click Insert Code here, or you can type Alt and Insert, and it's going to, wherever the cursor is, allow you to automatically generate some code here. And you'll notice that one of the options is a constructor. So if I pick this, it's going to ask me, based on the properties that we've already defined as these private instance variables, which one of these do I want to be initialized by the constructor. Now, we've already created one with nothing, so if I just click to generate right now, it would create this default constructor with nothing there. And if I selected all of them, then we would get something that looks like the constructor we just created. What I'd like to do is do one where I'm just going to pass it the name and nothing else. So click generate, make sure you select name, and then click generate, and you'll notice that it creates a candy bar constructor. We know that this is the constructor because it's the same name as the class. It expects a name, and it's going to set this.name to be name. Now what's important here is, since name is the same as the property and the parameter, we need to distinguish this. You notice if I highlight this name, it's referring to the parameter here, and if I highlight this one, it's referring to the actual instance variable. I know that this is the instance variable because I've got the this dot in front of it, so it's going to refer to or self-reference the context of the class that it's in here. Okay, so here is a nice way of generating our constructors. In this particular case, we could write them out manually, or we could have NetBeans, the IDE, do it for us if we click Source and Insert Code and then pick Constructor. Make sure that you are careful to correctly place the cursor, because if you put it in the middle of a method or a parameter there, somewhere, it's going to actually insert the code right there wherever the cursor is. So make sure that you've got that properly placed. Okay, so now let's actually come up with a couple of objects of the candy bar type. At this point, we can go into our main program and create a candy bar, and we'll call it my candy bar is equal to a new candy bar. And if I were to print out if I were to print this out at this point, what we should see is, since I'm not passing any parameters, this is the constructor that's going to be run, and so this is a nothing bar with 280 calories and weighing 2.07 ounces and costing 75 cents. In order to enable that capability, though, I'm going to have to do a little bit more work, because you'll notice that this candy bar's properties, or these private attributes here, are private. We can't get to them. So if I want to print out a candy bar, I need to add the toString function. So let's go ahead and do that now. And I want to make this method public. It's going to return a string. And if I can type properly, what we'll get is the ability to define this new toString function that's going to return a string. Okay. Now it's complaining to me right here as an error because I'm not returning anything yet, and I have to return a string. So let's return the name plus has this many calories, and it weighs. We could at this point just type in the weight instance variable, but let's format this actually nicely so that it comes out with a certain number of decimal points. I'm going to use the decimal format type, and I'm going to create an object of the decimal format called weight format. And it's going to be a new decimal format. And I want to format this as 2 precision points. Okay? And notice it's complaining that it doesn't know what the decimal format is. So let's just right click on this, and we'll fix the imports. And now it's not complaining to me, and you'll notice that it has imported java.text.decimal format. So it's actually quite nice. If you know what you'd like to do, but you don't know which package it's in, then just right click on the offending reference and just tell it to fix the import, and it will go ahead and add that up here into the top of your file. Okay, so now we're at the position where we can format this properly. Let's say we have our weight format, and I want to call the format function on my weight, and that's going to ensure that it's going to display this weight of the candy bar with 2 precision points to the right of the decimal point. It's that many ounces, and it costs... And now we'd like to do the same thing in formatting, and we want to format based on a price. So this will be another decimal format, and this will be a cost format. I'm going to call it a cost format. It's going to be a new decimal format, and this time I'm going to put the $sign there, which means that we're going to get something that's formatted as a price. Okay, so it costs, we'll use the cost format, and nicely it inserts this cost for us. Okay, and now we have constructed our string that should represent this particular candy bar object. So I just need to return, oops, sorry, we have it there. Okay, so we're returning the name, whatever the candy bar's name is, has this many calories, and it it weighs this much and it costs this much. Okay. Now you'll notice that we're still getting a warning here. The NetBeans IDE is complaining that we need to use the @override annotation, and we could actually compile this and it would run, but better would be to comply with this warning and put the override preface before this. The toString function is actually defined in the Java object class, and everything inside of Java implicitly inherits from this object class. So this is where we get the toString function. And if we weren't writing our own, then Java would handle the formatting if we tried to print this out and give us a reference and kind of print out some interestingly formatted nonsense to the average person. So what we'd like to do is override that toString function and define a new version of it ourselves. We can leave this off, but by adding the @override, we're explicitly saying that the toString function should override the toString definition as it was put into the object. It's just kind of a clarification in our code, and it's a good practice to follow. Okay, we've got our toString now. We have our constructors, and we have our private instance variables. So let's go back into main and actually create one of these new candy bars. I'm going to pass it parameters. This time, what I'm going to do is I'm going to say that I've got a 3 Musketeers candy bar, and it is 260 calories, and it weighs 2.13 ounces, and it costs us 70 cents. At this point, I can say system out println and print out my candy bar. Okay, simple enough program. All it's doing is creating one occurrence of the candy bar class. I'm going to call that object myCandyBar. I'm going to pass it these 4 parameters to fill in all of the private instance variables, and then I'm just going to print it out. So if we click run, what we get is the 3 Musketeers, which has 260 calories. It weighs 2.13 ounces, and it costs 70 cents. So you notice we've got our nice formatting here, and everything looks good. Fantastic. Okay, let's add some accessors and modifiers now. Let's go back into our candy bar class, and you'll notice that all of these are private, so I can't even read their values, which is not a good thing. What I need to do is use some getters and setters. Okay, so let's do this next. Let's come in here and add our getters, or our accessors. We'll put this underneath the 2 constructors. And let's say the first thing is going to be to get the name. Simple enough, I just return name. So now I can call getName, and it's going to tell me the name of the candy bar. And I could continue this with public int get calories. And I could return calories. Simple enough. Well, this is so simple it shouldn't surprise you that we can actually click on source and insert code, and then select the getter. Now notice that it's only giving me the cost and the weight because it knows that I've already done getters for the name and the calories. So let's just go ahead and select the two that we haven't done ourselves, and it's going to generate get cost and get weight for us, which return cost and weight respectively. So it just saves us the time of having to type this in ourselves. In addition to accessors, I can implement modifiers. So these need to be public. And so these are our setters. Well, we probably don't want to be able to set the calories or set the name. Those are somewhat fixed. So let's actually just implement the set weight. And I'm going to take in the new weight that you want to define for the candy bar. And maybe the weight goes down as you eat it. So I could say something as simple as weight is equal to new weight. And again, I'm using this underscore to begin, but that's just a stylistic option. And I could make this a little bit more elaborate to say something like if the new weight is greater than or equal to 0, then set the weight. And what this will do is guarantee that the weight will never become negative. Okay, so it's a good way to do some error checking on the code that we've got here. And rather than write the set cost, let's actually go under source and insert code. It's going to be a setter. And let's just pick cost and leave calories and names alone. And it's going to create the set cost function. I'm going to modify this slightly to say that if the cost is also greater than or equal to 0, then I'm going to set cost equal to cost. So one could argue that the automatic creation of the setter isn't the greatest thing in the world, but it does show you that it can be done automatically for us here. It's quite nice, and then we can go ahead and modify as needed. Okay, so back in main, let's actually go here and create a few different candy bars. I have the My Candy Bar, which I've created as a Three Musketeer, and I print that out. Let's create a new one called Your Candy Bar. And for this one, I'm not going to use any parameters to the constructor. So it should give us the default no name or nothing bar with the default 280 calories and so forth. So let's just verify that by printing it. And let's run this real quick by hitting F6. And you'll see that we have a Three Musketeers as we had before, and we also have a nothing bar which has the default 280 calories, 2.07 ounces, and 75 cents for the cost. Well, let's modify this now. And let's say something to the effect of your candy bar dot, and we have our set cost and set weight that we've defined now. And let's say that this thing doesn't cost 75 cents, but it actually costs $1. And we've also got our set weight. So let's say that it actually weighs a bit more. That's why it's more expensive. Okay. And let's print out Your Candy Bar again after the modifications. So we've created our Three Musketeers. We create the Your Candy Bar. We print it out here. But then we modify it, and then we're going to print it out again. And what we should see is the nothing bar has 280 calories, but then we should also see that the weight has changed and the cost has changed on this last line. So here's our nothing bar, and you'll notice that the weight has gone up, and the cost has also gone up. So this just shows you a way of using the setters that we just defined in our class. Alright, the next thing I'd like to do is add a method into my candy bar. In addition to my getters and setters and my constructor and my overridden toString, let's create a simple method called calculate calorie cost. I want this to be public, and I want it to return a double. And what I'd like for it to do is do a simple calculation that returns the calories divided by the cost. So let's say that we are a student and we're trying to maximize the amount of caloric intake that we have on the limited budget that we have. So you want to make sure that you're buying the candy bar that has the most calories for the money that you're putting into it. Okay, so we just defined this new function, calculate calorie cost. It's going to return a double and it takes no parameters in this case. And back here in main, I can define how many calories this thing has. To begin with, let's create a new decimal format, which I'll call ratio format. This is almost exactly the same as we did inside of the class in the toString, because I want the information to be displayed with 2 significant digits. And let's do a system out println and display this candy bar has, and then I want to format this output. Let's go with your candy bar dot calculate calorie cost. So you'll see this method that we just defined, calculate calorie cost. I'm going to invoke that method on the candy bar we just created, and then I'm going to format the output using this ratio format. So it has that many calories per dollar. Okay, that finishes that up. The error that we're getting here is that decimal format is not understood. So if we right-click and say Fix Imports, then you'll see the Import Java Text Decimal Format is added in, and now our program will run. What we should get is the original output, but now the nothing bar, this new candy bar, this your candy bar, should have a line here that says it has 280 calories per dollar, and that makes sense because the candy bar has 280 calories and it costs exactly $1. Let's do the same thing though. Let's say your candy bar has, and perhaps my candy bar has. Make sure that you change the candy bar that we're looking at here to the my candy bar, otherwise what you'll get is just a cut and paste error essentially. And now if we run this again, we'll see that your candy bar has 280 calories per dollar and my candy bar has 371.43 calories per dollar. Notice this is the 260 divided by 0.7, and that's going to give us our 371.43. So if you had to pick which candy bar you were going to eat and you only had $1 and you wanted to make sure that you were getting as much energy as possible, then you should pick the Three Musketeers over the nothing bar. The last thing I'd like to do now is give the candy bar the ability to compare itself to another candy bar. And so let's go into the candy bar class definition, and at the bottom of this what we need to do is override the equals function. The equals function is a public method that returns a boolean called equals, and it's going to take in an object, and we're going to compare whether this candy bar, the this that we're in here with this class, is equal to this other object. Now, by default, the equals method in the object class in Java just looks to see is the object reference pointing to the same thing. And what we like to do instead is actually compare all of the different instance variables one by one to determine if we have an equivalence. So the first thing we need to do is to make sure that, this object coming in is actually a candy bar. It doesn't make sense for me to compare a candy bar to an apple or to a fruit or something like this. So the first thing I can say is that if O is an instance of candy bar. So if it's not, then clearly this candy bar that I'm in is not equal to this thing that's not even a candy bar. So we're taking in object O, and if O is not an instance of a candy bar, meaning O is some other type of instance of a different type of class, if that's the case, then we're going to say, hey, these things aren't equal, and just return false. Otherwise, I'm going to do a comparison on the name and the calories and the weight and the cost one by one for each one of these instance variables. And it's just a large Boolean expression to say, is the name of this particular object equal to O? And the problem is, now I'm still comparing this object to my candy bar. So let's create a temporary to compare, and I'm going to make that equal to the O and forcibly typecast O into a candy bar. So we know that O must be a candy bar, otherwise this would have gotten us out of this function. So at this point we know that O can be typecast into a candy bar, and if you recall, this is the way that we do a typecast. We force one type into another, so we're forcing the object O into a candy bar called toCompare. So now I can say something like toCompare.name. So is the name of this candy bar equal to the name of this one that I'm comparing? If that's the case, I'm going to keep proceeding here. I'm not done. So that must be true, and the calories of this candy bar must be equal to compare calories. And if the name and the calories match, I need to compare the weight. Now the problem with double values that we've used, the weight and the cost in these candy bars are of type double. And when that's the case, we need to have a little bit of room for error. That way, if they're close enough, then we're going to say that they're the same. And the best way to do this is to do a subtraction. To say, I want to take the weight of this candy bar and subtract from it the weight of the candy bar that I'm comparing it to, and as long as the absolute value, or the difference between those, is less than 0.0001, then I'm going to assume that they're equivalent. And I'm going to do the same thing on the cost. And as long as the costs are only difference in such a minuscule area, then I'm going to assume that they're the same. Okay? So let me add my semicolon in, and then we're good here. One too many parentheses. Okay? There it is. I thought I had it right. Okay, so I'm going to take the absolute value of the subtraction of the cost minus the toCompare cost, and as long as it's less than 0.0001, and the same thing with the weight, and as long as the calories match, and as long as the names are equal to each other, I'm going to do a Boolean AND on all of these. So if all of these things are true, then I'm going to return true. If there's any difference in any of these instance variables, then it's going to return false, meaning the objects are not equal to each other. And you'll notice that since equals is defined in object, I need my at override here. Okay, so now we have our equals method. We still have a warning, and we'll come to this hash code in a second, but let's leave that for now. And now, back in my main, I can do a comparison. I can say, is your candy bar equal to my candy bar? And just by looking at this, we should know that this is not true, because the cost and the weight and the name are all different here. But just for the sake of argument, let's create a new method display equal that's going to take two candy bars, candy bar 1 and candy bar 2, or CB1 and CB2. And if CB1 equals CB2, then I'm going to say system out println these two candy bars are equal. Otherwise, I'm going to say that they are not equal. Very simple function, but it's kind of nice because now we can show that I can pass in two objects, in this case two candy bars, and I'm going to use my equals function that I just defined to say, is the first candy bar equal to the second candy bar? Now I don't want to say something like if CB1 is equal to CB2, because that's going to say, are they pointing to the same thing? And that's not really what I'm looking for here. What I'd like to do is do my pairwise comparison on all of the instance variables and see if they actually have the same name and the weight and the calories and the cost. If all four of those things are the same, then we're going to say that the candy bars are equal to each other. So, now that we have this new function, display equals, let's call it on my candy bar and your candy bar. And what do you think we're going to get? Well, we should get that these two candy bars are not equal. So let's run. What's our error? Display equal, not display equals. So, sorry for that. Let's run it again. It's a good example of making sure that you're being consistent in how you define and how you run. And here we have these two candy bars are not equal. And that's to be expected because, see, we have different weights, right? Different caloric information, different cost, and certainly different names. Let's go back up here into main, though, and let's create a different candy bar. We'll call it his candy bar, and we'll set this to be equal to your candy bar. Now, actually, his candy bar and your candy bar are pointing to the same thing, so they should actually return true here. One would hope. So, if I pass his candy bar and your candy bar, we've actually made both of these object references point to the same place. So hopefully we'll get that they are equals in our last line here. And these two candy bars are equal. That's good. Okay, so that's a good test. Let's actually create another candy bar. I'm going to go back up here to my Three Musketeers. Paste that in. Oops. Let's paste this in and call it her candy bar. I'm going to actually give it the same name, the same weight, the same caloric information, and the same cost. And just to be sure, I'm going to println her candy bar to show that it matches. So if we run this with F6, we get Three Musketeers, has 260 calories, weighs 2.130 ounces, and costs 70 cents, which is the exact match of the top candy bar that we have here. So we have her candy bar, and we have my candy bar. So, if we call display equals on her candy bar and my candy bar, this is the one that we defined here. Hopefully in the last line we should get that they are equal. Even though they're pointing to separate spaces in memory, since they have all four of their instance variables the same, then we should get this output that these two candy bars are equal. So let's run. And we get that these two candy bars are indeed equal. Good, that's exactly what we wanted. Okay, one more thing. Remember I said that we'd come back to this issue of a hash code? The equals method, as we overrode it, allows us to do this pairwise comparison, and we definitely need that for the simple code that we've written here. But we're getting a warning. Again, all of this compiles and runs just fine, but we do have a warning saying that we're missing this hash code. Now, hash code will be very useful to us actually towards the end of this course when we're working with collections and hash tables. But for now, it's sufficient to put the cursor down here at the bottom of the class, go under Source, Insert Code, and pick Hash Code. and just go ahead and leave by default all of the different properties. And NetBeans is going to insert this code for us automatically. And what the hashcode function does is it takes the values of all of the different properties, in this case the name, the calories, the weight, and the cost, and what it'll do is it's going to distill that down into a single integer that represents all of those values. Now, it could be that multiple objects with slightly different values for their instance variables will hash to the same integer, but if our hash code is designed well, this probability should be fairly small. So, it's important to notice that the hash code is going to be the same. If I have name, calories, weight, and cost that are the same, then the hash code is going to return the same integer. That's really important, and it actually makes working with data structures and collections much more efficient later in our program. For now, and when I say program, I mean this course, not this particular program. So for now, just remember that you can do source, insert code, and pick hash table or hash code, and it'll automatically generate this for you. And notice now that the warning is gone off of the equals function. So good programming standard is if you're using equals and you're overriding equals, then you need to also override hash code. It's nice that NetBeans will do this for us. And just to verify that all is well, if we come back here into main and we run the program, then we get the exact same output as we got before. And that finishes up this tutorial. What you should have learned out of this is a refresher course on how to define classes, how to define instance variables within those classes, how to create constructors and overload those constructors to take in 0 or more different parameters and set up all the different instance variables based on those parameters. We also defined a public method that did a little bit of computation and returned a integer, in this case, a double, in which case the calculate calories cost was our function there. We also implemented the toString function, which printed out our object nicely to the screen, and we implemented the equals function, which let us do a pairwise comparison between the instance variables of two different objects. Inside of the main function, we then made use of these classes by creating different objects of that class type, in this case creating multiple candy bars, and made use of the equals and the toString by displaying them to the screen. The last thing we've got here is the fact that we've defined a function called displayEqual that takes in objects of the candy bar type and does some simple computation on them, in this case doing a comparison. So it's a fairly elaborate and good review of defining classes and then making use of them. And now I'm going to go eat my candy bar.